Okay, so if we look at our first difference here, to get from 4 to 1 is it's minus 3. It is working, it's just turned on because some people complain. How do we get from 1 to 0? Okay. So, is that constant? No. Okay. So it's not linear. How do we get from negative 3 to negative 1? It's like adventures in adding integers here. So it's plus 2. How do we get from negative 1? Okay, so since this second difference is constant, that means yes, indeed, we have a happy quadratic function. So this one, since this isn't common anywhere, this is just not any kind of function we know. Wait, what? Because they're asking. We put the first difference up here just to show this is what we did earlier in the year when we talked about sequences. We just called this the common difference because that's all we knew, and we looked to see if that amount was constant to tell if the function was linear or not. Okay, and we still need to figure this out. But if we see, well, our first difference isn't constant, so we keep going to see if we can find out what kind of function it is. So we go to the second difference, or the difference of the first differences. Because remember, earlier in the year, okay? All right, we'll get in your time machine. Okay, if we had x and y values to look like this, and we took that first difference, what would we get? Plus 2. And you'd say, oh, this makes a linear function. So the first difference, if it's constant, it is linear. It's just a test to see if the function is this. The second difference is a test to see if the function is quadratic. No, this is not linear. Okay. I know, now I'm confused. You can go as many as you want. Like if we had a function that was x to the 10th plus 1, then you would only see a constant pattern at the 10th difference. Not that we would do that, but you could. All right, 23, you want to see is this quadratic or not. So if they give you a function, we just need to rewrite it so it looks something like that, which means y needs to be all by itself. So we can add 11. If we do it to one side, so we end up with y and 3x squared plus x plus 11. So this is quadratic. You could. Do we have to? Do we have an x squared? So it is. There you go. If the highest term, or the highest degree, is 2, then it's quadratic. It's not that they all have to be on one side, it's that y has to be by itself. Okay? Because let's say, what if the problem was, I don't know. Could we say this is quadratic? No, because y is not by itself. How would you get y by itself? Oh. The square root, which is the opposite of squaring a number. So we would actually have to take the square root of all that, and then the square root of x squared would be x. It wouldn't really work out that nicely, but it wouldn't be quadratic anymore. So just because you see the x squared doesn't necessarily mean it's going to be quadratic. When y is by itself, your highest degree should be 2. That's how you check. Generally, I don't want to say yes, because then you'll get one that isn't, and then you'll be like, but Mr. Ellis told me it always is like this. Or would it be wrong where x would be the only one squared? How would it be wrong? If you had... Okay? Because then you would have to divide x squared by x, which would give you x, and then x divided by x is 1, thank you. And suddenly, is this quadratic anymore? No. What? Yes, that's what you're looking for. Y by itself, highest degree of x is 2. And we can spend all day thinking of examples that aren't going to work, but that's sort of redundant. Could be. Yeah. Anything you can write in terms of y equals something is some kind of function. A mess. Well, try it out. X, Y. Okay, while Roger does that, we're going to move on because we've only done 2 problems in 20 minutes. No? I think it's confusing because we go over one question and it's like, let's look at 12 counterexamples of stuff that's way more complicated than we would ever need to do. But I need to know if this way will work. All right. If they give you the numbers like this, if you don't like looking at them like that, can we make a table of values? Yes. So what are our x values?
0, 1, 2, 4.
Right. What are our corresponding y values?
-3, -2, 1, 8.
All right. Do we have a constant change for x? This is +1, that's good. All right. So we look for our first difference. So we're testing to see if it's linear. For the people confused. So how do we get from -3 to -2? +1. How do we get from -2? Okay, so is this linear? No, because it's not constant. These numbers are not all the same. Okay. When we say constant, I mean they're all the same. Are these all the same exact number? No. Okay, this is not linear. So we go to the second difference. How do we get from plus 1 to plus 3? So is that constant? Yes. So this is quadratic. Both. Yes. If all these were the exact same number, it'd be linear and you'd be done. Okay? Just like, where are my slides? Like this one. We got plus 2, plus 2, plus 2. We're finished. Yeah.
But if you have to do it again, and they're the same, then it's quadratic. If
Yes.
they don't match, then what?
In terms of what we're doing this year, if they don't match, you're done and you say, I don't like this problem anymore. Okay?
So you just say like, what do you put?
You put no, not quadratic. Okay? If they're not constant, you can't call it anything yet. It's not until you find the constant term that you can start naming it. Okay? Remember, all we care about for like the next 2 weeks is yes quadratic, no quadratic. Okay? Not even, the only reason we even talked about things being linear is because you guys asked me like 40 times, what is the point of doing this? Okay? There are no linear equations this week. Okay? That's your hint. If you start drawing straight lines as your graph, you're probably doing something wrong. And by probably, I mean absolutely. Sure, fine. All right, 25. Is y by itself? Yes. What is our highest degree? 2. So is this quadratic? No, because y is by itself. Okay. I know you guys are making this like 100 times more complicated than it needs to be. All right, 26. This is different now. This is asking you use a table of values. Okay, so we're gonna have to make a table. Then do it in your notebook or on the back. So, what do we say were our new favorite values for x? No, because with linear it doesn't matter if it's negative or not. What? That's what I put. I don't know, I thought Trigo was just telling me what her grade was. Snap, snap. You know, 100 minus 1. I don't know why you guys make it seem like I'm being mean. Okay, so we substitute our x values in. So we say, what is negative 2 squared minus 5? Okay, so to save ourselves some embarrassment of not remembering how to add and subtract, what's negative 2 squared? Pause. Okay, all right. Negative 2 times negative 2 is? Okay. Hush. Yes, at least half of you are wrong. I accept that. Okay, 4 minus 5 is Yes, I'm aware some of you said that, but some of you also said +1, 9, -9, and other. Actually, I thought that's what Trigo was shouting out the first time. She kept saying -1. I thought I'd already worked it out, which is why I kind of wasn't acknowledging her. Because I thought she was ahead of us. I'm sorry. I was trying to give you credit for doing good work, and now you're hollering at me. We go to the next one. So -1 squared minus 5. It's -4. If you need a calculator for this, you're doing something wrong. Okay, next one. 0 squared minus 5. 0 times 0. You're thinking of any number to the 0. That's different. 0 to the any power is 0. The only real ones you have to put in parentheses are the negatives so that you know that the negative is being squared as well. Remember we talked about the difference between -1 squared and that. How this was 1 squared and then you make it negative, and we don't want to do that. All right. I don't care anymore. Okay, 1 squared minus 5 is what? Who taught any of you math? I'm not taking credit for anyone who just said the answer was 6. Yesterday was Sunday. We get it between classes. We got work to do. You'll make it. Okay. And the last one. At this point, you should not be waiting for me to tell you what to multiply. Okay. Yes. Okay. Yes, this was quadratic. We knew that because it's written for us. Okay. The reason we did this is because in the dinosaur days, before we had calculators, if you wanted to graph it, you would need a collection of points in which to graph. So you could then take these 5 ordered pairs and make the graph of this equation. Okay? So why do we do that? Because most of your phones don't actually graph functions. Okay. I don't care what apps you have. All right, so 27, 28, the same thing. 29 too, yes, very good. No, I can't. You can substitute in numbers and solve. I believe in you. 30 through 32, tell whether they open up or down. What did we say? How do we tell if it goes up or down? Not the x squared. A is positive. Positive. A is negative. Okay. you should write that down like 100 times. You know? Instead of I heart 1D or I heart JB, you should put I heart y equals ax squared plus b. JB. Okay, so the only thing you need to keep in mind here, before we can look at if A is positive or negative, y has to be all by itself. So number 30, does it open up or down? Up. And 31, 32, you guys can figure out. Yes. Okay. Please don't shout stuff out. Okay. All right, 33, it says, what is the vertex? Yes, it matters very much. Y has to be positive. Okay. So we said vertex was what? Was the turning point. That's a good word. It gets to be an ordered pair. So don't say -5, you'd say 0, -5. Okay? Does this have a minimum or a maximum value? Minimum. The lowest this can be is, well, what's the minimum y value? Okay. So when you put the vertex, you put an ordered pair. If you're putting minimum, that's when you can just put the y value. The max is the opposite of min. Not women. All right, 34. The vertex is 1, -3. This has a maximum. Okay. Domain and range. We need to remember, what does domain mean? The x values. So what are the possible x values for this? Negative. Wait, I don't really mean to say negative. I meant to say no. That's not right. Since this is a line, well, not technically a line, but it continues on forever, what is the highest x value you could get? What? The highest number you get is 0? This goes on forever. And so what are possible x values? Everything. What's the better way to write everything? No. All real. Okay. Is that going to be true for all these? Why not? Yes. Okay. So, yeah, you try to find one that doesn't. Oh, okay, great. All right. Range is where you actually have to do a little bit of work. What is the range of values? 0 to down. Sweet. How could we write that? Well, it has to be less than or equal to 0. 0 and down. Okay. Does this relate to the last thing we did with minimum and maximum?
No.
Yes. Because we say our maximum is 0, which means the values have to be something less than or equal to 0. Yes. Okay, so your homework is the rest. You finished those.